Good evening everyone, my name is AMAN Singh and today we will be learning about decorators. A decorator in Python is a function that takes another function as its argument and returns yet another function. Decorators can be extremely useful as they allow extension of an existing function without any modification to the original function source code. Let's say function is argument, therefore these are prerequisites we will cover in functions. You can think of decorators as you have a gift and you wrap it, you add another functionality to the gift. Therefore the gift you can consider as a function and you are wrapping it, therefore wrap. Decorators are also called as wrappers. Therefore you can you added a functionality by wrapping it. Therefore the work of wrapper is same as that of a decorators in Python. What are function? Function are employed to do specific tasks. They are first class objects in Python. What do you mean by first class objects? Like we can store the function in a variable. Therefore we created a function, new function f1, print TECHNOIDS, and we stored new f1 function in a variable, store variable as function, and when we call that variable the new function is called and then we get the TECHNOIDS printed as the output. Then we can define it as the function and we can return the function from a function. We create a new object and a new function f1, then we print TECHNOIDS, we create another object new f2 or function, then we print Python bootcamp and we return a function to new f1. New f2 doesn't have a return, we are returning new f2 to f1. Therefore when we call new function f1, then the TECHNOIDS is printed. This is the order that the code will be executed. Then object or function is created in the memory new f2 and then we call the new f2 function by calling an f1. Therefore TECHNOIDS and Python bootcamp are printed. Now we can pass the function as a parameter to another function. Like we created a add function. These print statements are just following where we are. Then we created result as a plus b, or you can write it as result return a plus b, anything is fine. We created another function intermediate add, we pass any function to it as parameter and a comma b. Print inside intermediate function return any function a comma b. We are passing this as a return to this function intermediate. Then we print intermediate add we are passing it as an argument and 10 and 20 as argument are the exact values that we are passing. Like here is any function which can be any function, here we are specifying the add. Therefore how it's execute it, intermediate add, it goes to this function, it takes its arguments, then it print intermediate function, then return any function a comma b. Here it goes to this function add and then it takes its parameter 10 20, then result we get at 10 plus 20 30, then it returns the result. This function is called, therefore we get the 30 as the output. Now we can store them in data structures such as list. We define one more function, subtract result absolute with a built-in function a minus b here which will positive value, therefore return result list equal to add comma subtract. This is the list as you can see by the brackets. Then we print list 0, which is we start counting from 0, therefore 0, then 1, then we get 10 and 20. I am passing it as a argument to this function result which I created before, and then subtract, I am passing 10 and 20, therefore we get 30 and 10 as a output. Now let's study about namespace. That's all about function. Namespace. For studying namespace, first we get to know a function, this dir function. It returns list of the attributes and methods of any objects. Like I input a string AMAN SINGH TECHNOIDS, then then dir name, then it will give all the functionality, all the built-in function it has, like all the functionalities I can apply, like is alpha, is numeric, like I could check boolean values, that all things which I could apply to it will be available, like count and index, you can find it. And if no parameter are passed, it return a list of names in the current local scope. Like a is equal to 1, like if I print dir here, just a second. Add another block of code, then dir, then A I have defined before, therefore it will be given before only. Just a second. This yeah, A is equal to 1 has been defined, therefore before only. Let me run it, like it should give this up. Let me one second again. I run it. Before second go there. It's giving all the values. Yeah, I think I've run this code before, but giving previous values also. Like A is not defined in this local namespace, this A. Therefore, just a second, I'll open this terminal. Python. Then I create a function new f1, and I print TECHNOIDS in it, and then I any function A is equal to 1 also I type it, and then I dir it. It is giving like A and new f1 are created here. But if I open another terminal and I type Python here and then I dir it, then you can see that A and new f1 are not present in this namespace, local space. Therefore, I think I have run this code before, therefore it was giving some error. Let's leave it to it. I am using Google Lab only. If Jakarta Notebook, I think it's not given errors. Just a second. I delete this piece of code. Like here, now you can see like A is equal to 1, print A is equal to 1, and then A is equal to 1, therefore A is present here. And new f1, new f2, like I've run the code before only, like this new f1, new f2, therefore the things which I have run before only, it is still present in this code. Let me create output. Anywhere I have clear outputs. Let me check it again. Maybe now I'll get right output. Here only I was. This, no, it is still executing all the code. New f1, new f2, everything I'm getting. Therefore I have explained this in terminal, like you will not get more dir when you will execute in your code. Then A is equal to 2 and print A. The A variable is present in local namespace. Therefore, when I change the value A is equal to 1 to A is equal to 2, and then I print it, then you can see the value of A has changed. But if I do something like here, like I create a new function inside this is a local namespace of this function. Therefore, if I put something like A plus 1 here, and then I try to execute the code, it will give error because the A plus 1 it is not defined in this namespace. Therefore, if you put A is equal to A plus 1, it is not defined, therefore it will not take it as like A plus 1. It doesn't know which A to add because it's not defined. It would give an error. See, I use the dir function here, and therefore dir of this is the namespace of function 1, and I pass dir. Then you can see that the namespace are A and B variables because A and B are only I have defined. And second function using dir, A and C is defined, which is this A and C. Then I print new f1, new f2, which is returning a value in both. It is 20, it is 10, therefore 10, 20. But the global namespace, which is a outside, which I have defined here, then here you can see that when I print it gives me an output of 2. Therefore you can see that a has value of 2, a has value of 10, a has value of 20, but they are in different namespaces. Therefore but if I want to do that, which I wanted to do here, but I didn't add a keyword global here. Therefore if I add a keyword global a, then I could take the which variable I have defined here. I could which I have defined here, a is equal to 2. Then I could change it. It is similar as a is equal to a plus 1, as you had studied. It performs the same function. It is just a better way, efficient way to write a is equal to a plus 1. Global a, then you can change it. Then when you return a, then you will see that the output of this new f1 I am talking about will be 3. 2 plus 1 is equal to 3. And then we have new function 2, ac, and then it's the same output 20 we will get. Then we have, and the global variable, you can see its value is also changed, not in this namespace only, because the last value is also 3. The global value of a has changed. Now we define when we define new function b is equal to f1, b is equal to 20, we have assigned the value of b is equal to 20. We have defined another function, new f2, a is equal to 100, print a comma. But here when I say b, see, b is not present in this namespace, but when I execute this code doesn't give me error. Why? Because this first find the value in this namespace, then it goes to this namespace which is in this, then it goes to the global namespace. Therefore I have asked the value of b, I am not modifying it. If here also, if I would be modifying it, b equal to b plus equal to 1. If I am modifying it, would give me an error, because you cannot edit it, but you can read the value by which is outside the local namespace. Therefore new f2 and then print b comma b here. Now it will execute because I have removed that statement, and then we can get the value new f1 I executed, then this will execute, b value is 20, a will be printed, then b will be printed, then this b will be printed. Now if I want to change the value of, because it is when you see this here, there is only two namespaces, this namespace and the outer side of which is a global. It is a local namespace, and this is a global namespace where I have mentioned a is equal to 2. Therefore there are only two. Here there are three namespaces, this is namespace, local namespace, then it is enclosed, it is by special name enclosed namespace, because it is between local and global variable, a global namespace. Therefore the outer is global namespace. Therefore if I have to call a variable which is in edit it, change it, value which is in enclosed namespace, this is local namespace, this is enclosed namespace. Therefore the value is b is equal to 20, and I have to change it. Therefore I have to use a special keyword, non-local b is equal to b plus 1. Therefore now I can change the value of b. There I have changed. Now you can see that when I'll call it, then it will be a 100, b nested 21 because I have changed it, and b 21 because if you change it here, the value here also has been changed because you have used a keyword. The process, how it searches for the values, this is the function. We use this formula. I'll explain it like this function. I mentioned a is equal to 10 here, so therefore when I run it, you will get a is equal to 10 here, and then I commented that line. Therefore there is no value of a in this local namespace. Therefore it will search above level of it, that is enclosed namespace. Therefore when I run, then I'll get 20 as output. Then if I comment this also, then my global is this namespace. Therefore when I run, I'll get 1 as output. Therefore it follows this procedure, like if it is in local, then it will take local one. If it's not present, it will go to enclosed. If it's not present, then it will be global. Built-in, just leave it for now. Like a built-in function, it will refer when we import modules and all. Therefore I'm not using that built-in. We have to work around only this local, enclosed and global. We have to understand it. Built-in, you can use this function to know what a built-in function and how many built-in functions are there. There's 156. This I have been verified, and then we create a new function f1 a is equal to 20. Here we are learning about a new concept, a closure. What is a closure? A closure is a function object that remembers value in enclosing scopes even if they are not present in memory. See, 3 conditions here mentioned. Now you can see the first condition. We must have a nested function. This is a new function f1. We have another function f2, and this new function f2 is nested function because it is inside new function f1. Therefore first condition is fulfilled. The nested function must refer to a value defined in enclosing function. Enclosing function value defined is equal to 20. The nested function must refer to a value defined in enclosing function, or you can pass an argument here and that value it can refer. The enclosing function must return the nested function. Like this is the enclosing function, def new f1. Enclosing function, this is the nested function. Enclosing function must return a value, must return the nested function new f2. This, and then we can assign variables with functions. Therefore g is equal to new f1. Therefore when we call g, then new f1 will be called. Here we are printing g dot name. Therefore we will get a new function f2 because they are both pointing to the same function, like g and new f2. They are same only. Therefore if I call, like if I comment this, let's just comment, and if I call new f2 outside of its local namespace, like variable their function namespace, then it should, like new f2, if I call a comma c, I think new function I have defined anywhere else also, giving me that output. Let's just new function at 2 should not give me an output because it is outside the namespace of this new f2. New f2, like I just changed the function name so that it's not new f10. I think that function was defined before, therefore it was taking previous, like Google Colab stores results output. Therefore I am not using Python notebook, therefore it has stored for only. Therefore I'll just change the function name f19 so that no issues are caused further. Like if you call this new function, you cannot address it, but when you call from, I'll change the function name 19 this, then you can refer to this function outside of the local namespace of this function. If you again, if I call new f10, it will not execute because it's outside that namespace. Previous issue was caused due to the namespace, like a memory error. It has stored new f2 before only and it was executing. Now with decorators, now this was the prerequisite, we completed it. Now we have Now we can study decorators. Any callable Python object that is used to modify a function or class. Simple. Then there are two types of function decorator: function decorator and class decorator. We'll study only about function decorators in this session. Let's just delete it. Now this is only the main part. Now we have a function. This is the decorator function. This is a normal. First start with a normal function. We define a function TECHNOIDS string, which returns TECHNOIDS string as string data type. Then we define our decorator function to make this TECHNOIDS lowercase. Therefore, lowercase, dot lower is the built-in function of string. Therefore, operation algorithm, we want a functionality which we want to add to this function. Therefore, we define operation algorithm. This is the nested function. Like you will see this, we must have a nested function. First criteria is fulfilled. The string 2 is equal to function. Function is a parameter here. Then we pass this parameter to string 2. We store it in a variable, you can say. Then the nested function must refer to a value defined in the enclosing function. This is the nested function. This is the enclosing function. Therefore, it is defined. Then return string 2 dot lower. Dot lower just lower cases all the alphabets in TECHNOIDS, which is only T is uppercase in this case. Then we return operation algorithm, which is the nested function. The enclosing function must return the nested function. All these three criteria are fulfilled. Now these two are like, if I just like this, if I remove this line and then I execute this code, they will get TCapture. The functionality of this is like a special symbol to indicate this is the decorator function. Decorator function name is this. We use @ and the decorator function name to indicate that this function has a decoration, and therefore it will search for this, and then the parameter which was passed to that parameters will be passed to this decorator function, and will get the output by applying with the algorithm which we have applied in the decorator function. Will get that output. Like if I run this, then all will be lower, that is the T. Now if we decorator is like, there is only one decorator function here, and there is a function which we should not modify. Therefore, in this, if like I did not change this function, the first thing, and I added another functionality to it using decorators function, then the same string I wanted to use split, therefore I extended the string, or I could use split at certain point, but I didn't want to use it. Therefore, for simplicity, I increased the string length. We define a string object or function, and we return this string. This string, we define a decorator. There are two decorators. This is the first decorator. This is the second decorator. We define operation algorithm, which operation we want to perform. We store it in a variable, and we apply the upper built-in function to this string, which is passed on to this, and then this, then this. And then we return this nested function to the enclosed function, which is this. Then the same thing here also, function is as a parameter, then operation algo 1, I just changed the name, string 3 I've stored, then split, then return this nested function to this enclosed function, and then we are using this at the rate deck upper for this decorator, and at the rate split for this decorator. If you do not use this, then this function will not know that it has a decorator linked to it. This for linking both. Therefore, if I put this, then what will happen is it will convert it into uppercase and then split it. Yeah, and if like in this case, like if you use this, it will give an error because you cannot apply upper to the split string, like to the list you cannot apply it. Therefore it is an error. Like it would be list object has no attribute error, because split the 3 like a previous. If I'll show 1 minute previous output, this I'll show this is a list. You cannot apply upper built-in function to the list, only to string you can apply. Therefore it was giving an error when I interchange the position. Therefore by this the function, the decorator which is close to the original function, then that will be applied first, then the upper decorator will be applied second. It's just the order. Now we have how you can use it, like division function is there, a comma b. Now what we want to do is, like, if it is 0, then I want it to give like add an exception you have studied, then in that it should give something to me. Okay, the error it should give, like your input is wrong, something like that. For that I created a decorator function, and in decorator function I created a nested function. Decorator function, enclosed function, you can call it anything. In this example, operation will go a comma b are arguments, parameters here. If b is equal to 0, that is checking the condition. If this b is 0 or not, then it will return wrong input. Because it is 0, then we cannot divide. Then return function a comma b. The only difference is here. You will see that in this there are no parameters here, but in this we are passing parameters. Therefore that is the only difference between these two decorator function, so that you have idea of both, how to pass with parameter and how to do without parameter. Therefore return function a comma b. We return the function with parameters a comma b, and then we return the nested function to the enclosed function, and then when we attach the both decorator and this original function, and then we call this function with the arguments 1, 1. Then for this it is not necessary, but it has executed the function. But if I put 0, you will know that it has reached this function and the wrong output is given. And this is the main part. Like here we are not passing any parameters here. Here we are passing parameters, and then if b is equal to 0, we need to return this function only, a comma b, to this function. Then we return this function to this, and then we get the output. That's all for today, and hope you will be doing assignments. I'll upload the assignment in the GitHub, and you can check out, and I'll post in the Google Classroom also around 8. Okay, thank you.